Hi, ladies and gentlemen. This is Mr. Green, and this is another in my recordings for pre-cal. We're going to be looking at a new way of looking at coordinates today. So this is going to be an interesting way of doing things. Okay, where should we be? Well, we're looking at Unit 6. In Unit 6, we're going to build upon the stuff that we have done already with vertexes. I'm not vertexes with uh, um, geez. Oh, oh well, can't remember the name now. Okay, it walked out of my brain. What can I say? Anyway, we're going to build upon what we did in the last chapter and at the very end of it, and we're going to use that information and we're going to start talking about having polar coordinates. Polar coordinates is just a new way of recognizing where a point is located in space. Okay, so we're going to look at that. So, polar coordinates. We're going to look at a vector. That's the word I was looking for. We're going to look at the magnitude of the vector and its direction. And we're going to use magnitude and direction to be able to locate where a point is located. So what we're going to look at is the magnitude r and the direction, the angle of the vector in degrees. So we're going to be looking at a coordinate system like this where we've got a degree from here that we're going to be going up, and we're going to go so far up, and that's going to give us where the point is located. Okay? So that's how we're going to be looking at these at polar coordinates. So a lot of what we're going to do is converting from one type of coordinate system to another type of coordinate system. So if we're in polar coordinates here, we've got this r and we've got the angle. And if you take r times the cosine of the angle, it's going to give you the x value. And r times the sine of the angle will give you the y value. Why is that? Well, let's go back and look at this. If we're looking at this point right here that we just identified, well, right here is my x value, right? There's the x value for it. If we were looking in a normal coordinate system, well, this is the angle, this is the opposite side, right? And this is the hypotenuse. So if we take the cosine, which is I'm sorry, the that's here. Well, I'm trying to get to. I'm trying to get to the x value here, right? I'm wanting to find this value right here, right? So if I take the adjacent side times the cosine of the angle, cosine of theta is equal to the adjacent side, which is going to be the x value, divided by the hypotenuse there, or well, that's also the magnitude of the vector. And then I multiply this times the magnitude of the vector, I'm going to get what x is. That's how we're getting this x value here, this distance here. For the same way, we could do the y value. So the sine of theta is going to be equal to the y divided by r. So when we multiply this one by r, that's how we get that equation for that. That's how we can convert if we're given a polar coordinate to get a regular x and y coordinate, a rectangular coordinate. Now, if we've got rectangular coordinates and we want to find the polar coordinates, well, we can always just find the magnitude of the vector that's formed by it by using x squared plus y squared is going to be equal to r squared. So we can find the magnitude of it that way. We've done that in the past chapter. And then we can find the tangent of the angle is going to be the y divided by the x. We don't need to know the magnitude to do it. We just take y divided by the x. So let's try a couple things here. If I'm given the polar coordinates 6 and 45 degrees, to convert it to x and y, I'm just going to multiply 6 times cosine of 45 degrees, and I'm going to get 4.24. And y is going to be 6 times sine of 45 degrees, that's 4.24. So my point is going to be at 4.24 or 4.24. Does this make sense? Well, 45 degrees, think about it for just a second. 45 degrees is exactly equal, right? It's got 45 and 45 make the 90 degree in there, right? Remember that? So when I say that it's out here at 6 and 45, I would expect my x and my y values to be the same. So it is an isosceles triangle at this point. But I just wanted to make certain you recognize all I did was plug it into the equations to get those values. Let's look at one going the other way. If I'm given the point 3, 4, and I want to convert that to polar coordinates. So the tangent of the angle is going to be equal to 4 divided by 3. or y over x. So 4 divided by 3. So if I take the inverse tangent of 4 divided by 3, I get 53 degrees. So to find the magnitude of the angle of the vector, I'm going to take 3 squared plus 4 squared, or 9 plus 16. And that's going to be 25, and the square root of that is 5. So my magnitude is 5. My polar coordinate would be at 5 and 53 degrees. Interesting. So you're going to be able to convert from one to the other. Shouldn't be any problem there. Okay? Now, someone once pointed out that what happens when x is equal to 0? I mean, if we go back and we look at this, what if my x value were 0 here? Then what we'd be looking at is a point that's sitting right here on the y-axis, right? Well, x is equal to 0. I'm dividing by 0. Oh no, that's going to give us all sorts of different problems, isn't it? We can't do that. So what we have is, if x is greater than 0, we take the inverse tangent. If x is less than 0 and y is greater than or equal to 0, we take the inverse tangent of y divided by x plus pi. Okay? If x is less than 0 and y is less than 0, we're going to take the inverse tangent of y divided by x minus pi. If x is equal to 0 and y is greater than 0, the answer is pi over 2. If x is equal to 0 and y is less than 0, it's negative pi over 2. These here are the actual ways that most people use to convert these formulas here rather than this one. But I will tell you what, for the most part, you can use this one and get by with it. Okay? It brings up that point that was made at the beginning of this unit. When we're looking at polar coordinates, if I've got a point out here, there's multiple ways of looking at this. It could be this angle here that I'm looking at, theta, or it could be looking at this angle here that I'm looking at, theta prime, as a different theta. Okay? It could be this magnitude I'm looking at, or it could be a negative of this magnitude that I'm looking at. There's at least a couple different ways of looking at these polar coordinates every single time. And you have to be careful with them, because you have to be able to convert and recognize that when you're looking at an angle and a magnitude, there's always that opposite, that 360 minus that angle, and there's always the negative magnitude that you could be looking at. Okay? So be aware, there's some conversions of that you have to do too. Okay. So I do appreciate you guys letting me know that you're in pre-cal every time. It helps me keep my record straight, and it helps me respond when you ask questions, okay? I appreciate it, and I will talk to you in Class Connect this week. Bye.